Here are a couple more examples. Okay, so flip we're on page 3 now, and let's look up at this one. Now you'll notice that let's start at the top of the list once again. So we have our GCF, and we actually have one this time, which is x, and I can factor that out. And when I factor out the x, I'm left with x squared plus 7x plus 12. Once again, I don't think I felt too creative when I was making this up. And then we can look in here and we can say a times c equals 1 times 12 is 12. Okay. And 3, I'm looking for factors of 12 that add to 7. I've done this a few times already, but here's factors of 12 that add to 7. 1 and 12, 2 and 6, 3 and 4. 3 and 4 add to 7. And then I can box and factor. And I'm just going to keep bringing this x down. I'll just put it right there. Box and factor. And I'm going to put x squared here, 12 here, 3x here, 4x here. And common in this direction is 3. Common in this direction is x. Common in this direction is x. Common in this direction is 4. Double check everything. X times x, x squared. X times 3, 3x. X times 4, 4x. 4 times 3 is 12. So my two factors are going to be x plus 3 and x plus 4. And this would be the factored form of this cubic polynomial, trinomial. Alright, one last example of this and then we'll stop beating this dead horse. So, common factors. So 1, no GCF. GCF. Okay. 2, I'm going to multiply a times c. And 4 times negative 5 is negative 20. Okay. I'm going to look for factors of negative 20 that add to 8. And let's see, so that's going to be 1 and negative 20, negative 1 and 20, 2 and negative 10, negative 2 and positive 10, and 4 and negative 5, and negative 4 and positive 5. All those are factors of negative 20, different factor pairs. Negative 19, 19, negative 8, positive 8, negative 1, positive 1. So we're trying to find factors of AC that add to B. So factors of negative 20 that add to positive 8. So there would be my pairing. So I'll have 4x squared minus 2x plus 10x minus 5. Write out my box. X squared term goes in the top left. C goes in the bottom right. Put in some other stuff here. Okay. Now, common in this direction would be a positive 5. Now, whenever I have negative signs like this lined up, I'm almost always going to factor out a negative sign. Okay. But you'll notice that there's not really anything common, so you're just going to factor out a negative 1. Now, in common in this direction would be a 2 and an x, and I should double check that real quick. So 2x times 5 does equal 10x, so we like that. Now, what times negative 1 equals 2x? Well, another 2x. Okay. So let's double check everything. 2x times 2x is 4x squared. 2x times negative 1 is negative 2x. Negative 1 times 5 is negative 5. And 2x times 5 is positive 10. So my two factors are 2x minus 1, 2x plus 5. Okay. So now there's a couple of special cases we want to talk about here. One of them being, we've already dealt with one, which is perfect squares, but we're going to talk about difference of squares. Now you'll notice that these are each perfect squares. X squared and 9 is a perfect squared. And then there's a negative sign in between. Now, what we didn't realize is that in this case, there's always a middle term, okay? There's always a b. Sometimes, though, that b equals 0. So in this case, it equals 0. So we're looking for, if once again we do all our steps, right? There's no greatest common factor, okay? And we're looking for factors of AC that add to b, and my a times c would be -9, and my b is going to be 0. So the factors of -9 that add to 0 are going to be -3 and +3, and they add to 0. Okay, and then I can box and factor again, and I can say x squared and -9, and then these two terms go wherever. And common in this direction is going to be +3. Common in this direction is going to be -3, and the negative signs kind of point in that direction. X and x. And so my two factors are going to be x plus 3, x minus 3. Now, what you'll notice, what you may have started to notice, is that these match up with these when a equals 1. And that's true with all of these difference of squares patterns. Is always going to be the same numbers, right? The square roots of the c term, the square root of x squared, and then just plus and minus. So for example, if you had x squared minus 25, that's just going to factor as x minus 5, x plus 5. And so that's that pattern that'll kind of speed things up. So why don't you guys practice all these problems, and practice the problems on the next page, and we'll see you in the next class period.